Now each one of these can be converted into standard X and Y's, your Cartesian or rectangular coordinate system. Um, if you have a polar graph, though, it's easy to graph these, but there is one issue with polar coordinates versus Cartesian coordinates that you need to be aware of. And I'm going to kind of identify it by looking at this instance here. I want to plot these 4 points. So again, kind of going with what I did before, 3 comma pi over 6. I'm going to first locate where pi over 6 is. I'm going to scale it the same way. Pi over 6 would be pointing in that direction. Of course, the end of the arrow would be in the negative direction. I want to move 3 radii out, so I'd be here. So that's where A would be. Negative 3, 7 pi over 6. Well, 7 pi over 6 would point down here. Okay. Negative 3 means, again, where I'm at the center here, that's where 0 is. So I'm going to move in the direction opposite of where the arrowhead is. So I'm going to move 3 out that way. That puts me in the exact same location. 3 comma negative 11 pi over 6. Well, negative 11 pi over 6 would put me right here where pi over 6 is. Those are coterminal angles. If I move 3 radii out there, it puts me in the same position. And likewise, if I do negative 5 pi over 6, which we already talked about is coterminal with 7 pi over 6, and I move negative 3, which means, again, being the center being 0, I'm moving away from the arrowhead to be negative. That puts me there. So with polar coordinates, an ordered pair, I can have several different ordered pair that gives me the exact same point, whereas in Cartesian coordinates, or your standard, they sometimes call them rectangular coordinates, if I have different ordered pairs, they're going to be different points.